Hello guys, in this tutorial we will go over some NumPy functions that will help you to analyze your data. So let's get to it. So NumPy arrays for data analysis, okay? So as I mentioned in the previous NumPy tutorial, so NumPy is a data structure that will allow you to store data in it. Once your data is stored as a NumPy array, then at that point you can slice and dice your data in any way that you want. Not only that, you can also, start computing some standard aggregation functions such as the mean, median, standard deviation, and so on. Okay, so again, the purpose of this tutorial is just to go over some standard NumPy functions that will allow you to start exploring your data. Okay, so let's start with section 1, introduction. So NumPy arrays are the backbone of numerical and data analysis in Python. So beyond efficient storage and fast computation, NumPy provides a rich set of mathematical and statistical methods for data summarization, transformation, and analysis. So basically what that section is telling us is the following. So there are a bunch of Python libraries that rely on NumPy for data analysis purposes. Okay, so being familiar with how you can start analyzing your data with NumPy arrays is very, very important in data science, machine learning, AI in general. So yeah, so let's get to section number 2, mathematical and statistical methods. So NumPy offers built-in aggregation functions that operate over entire arrays or along a specific axis. Okay, so these methods are vectorized and implemented in C. So then that's the programming language. Okay, so if you're not familiar with C, so C is one of those programs that, even though that it was developed back, if I remember correctly, was developed back in the 70s, is still one of the fastest languages still today. Why? Because C was developed for the purpose of computation, so it's really, really fast. Okay, however, writing code in C for computational purposes is more involved. Okay, it's more involved. It requires a deep knowledge in terms of how the computer works, how you can allocate memory for the different data structures that you want to create, and how you want to perform those operations. So yeah, so NumPy again is being developed on C. So then that is one of the reasons that some of those functionalities that we have in NumPy are really fast. Okay, so yeah, ensuring high performance on large data sets. So section 2.1, so let's go over some standard aggregation methods. So if you are interested in computing the sum of the values that you have stored in your in one array, you can use the sum command. If you are interested on the mean or the average, you just use the mean command. For standard deviation and variance, you use std or var for variance. For minimum and maximum, you just use min or max. If you want to identify the index of the minimum, argmin. The index of the maximum, it will be rmax. If you want to find cumulative sum, so you just use cum sum. For cumulative product, you just cum product. Okay, so again, so those are a few standard functions that you may that you want to keep in mind if you start exploring your data. Okay, so let's go over the next sections that show some of the syntax related to these functions in NumPy. So for example, here first we are as usual, we are importing NumPy. Then here we are creating a two-dimensional array. It has 5 rows. and 4 columns. Basically, we are populating that array with this is random numbers from the standard normal population. So we are population. So we are populating that two-dimensional arrays with 5 rows and 4 columns with numbers that comes from the standard normal population. So that's normal 0, 1. Okay. So then technically speaking, we have 20 values there. Right. So we have 5 by 4. So then we have 5 rows and 4 columns. Okay. And then if you are interested on finding the mean of those 20 values, you just do that mean. And that will compute the overall mean. Okay, so if you are interested on finding the average of all of the values, you start by typing the name of the rate, that mean, and that will do the job. Now, what if you're interested in computing the mean across the rows or the mean across the columns? So in that case, you need to include an extra argument, so axis. So if you are interested in computing the mean column wise, so you need to include this command, axis equals to 0. Okay, no, excuse me. So if you're interested on finding the sum column wise, so you will need to include axis equal to 0, and that will compute the sum of the column. So it will add up all the values under column 1. So if we call this call 1, call 2, call 3, and call 4. So yeah, so that command right here, it will add all the values stored under column 1, then all the values stored under column 2, then it will add all the values under column 3, and it will add all the values under column 4. Let's say you're interested in computing now, let's say the standard deviation row wise. So you will use the std command and then axis equals to 1, and that will compute the standard deviation of each of the rows. So axis equals to 0 is for columns, for column wise operation, and axis equals to 1 is for row wise operation. So yeah, so then this command right here again, it will compute the standard deviation of all of the rows. Okay. All right, so then that's how you can include that argument axis, and depending on how you want to perform your operation, you will either, if you're working with a two-dimensional array, if you want to perform the operation column-wise, so then you need to include the axis equal to 0 argument. If you want to perform the operation row-wise, you will need the axis equals to 1 argument included there. Okay. All right. Let's go to the next section, which is cumulative methods. Again, this is another of those commands that you need to be aware of. Okay, cumulative sums and cumulative products. Okay, cumulative sums, they are very popular. Cumulative sums and cumulative products, both of them are popular, especially on finance or quantitative finance applications. Okay. So here is just a very simple example that will show how you can use this command. So then here we have a very simple and a very small array. So it has 3 elements, 2, 3, and 5. And if you are interested on finding the cumulative sum of that array, so then you just do cum sum. And then the output will be 2 because up to that point. So then when you have only one element, that will, if you add that element, it's just going to be the same value, 2. Then here you see 5 because this is 2 plus 3. And then here you see 10 because it's 2 plus 3 plus 5. Okay, so that's basically the cumulative sum. If you're interested on cumulative products, so then very similar. So then Up to that point, you only have one element, so then the output is just gonna be that element. Here you see 6 is because it's 2 times 3. Here you see 30 because it's 2 times 3 times 5. Okay, so those are two standard methods or functions, if you want to call it that way, that you have available to you in NumPy if you want to compute cumulative sums and cumulative products. You can also do Boolean aggregation, which I touched on that on the previous NumPy tutorial. Again, but then here is just from the data analysis perspective, right? So then there might be some scenarios in which you have a big array and then you're interested on, for example, counting the number of positive values that you have there, or check if you have any values, any negative values in there, or if you want to check if any of the values is greater than 2. Okay, so these are just three simple scenarios. Okay, so just for illustration purposes, again, we create a very simple array with random values from a normal distribution, and we have 100 of those. And then here, what we're doing is, this is a two-step process, right? So if we want to count how many positive values I have stored on the array called ARR, so first I need to perform the following: ARR greater than 0. So that is a Boolean operation. So then this is going to return either true or false. Okay, so true if that corresponding value happens to be greater than 0, false otherwise. So that is performed. So then that operation, ARR greater than 0, is going to generate another array with true and falses. So, and then at the end, we are doing the dot sum. So when it comes to true and false, so then true is treated as 1 and false is treated as 0. So when you perform the sum applied to that array with true and falses, so then it's gonna count the number of truths. Okay, so it's gonna be an integer, right? So if there is no true, so then you're gonna see 0. And if there is true, so it's just gonna count those truths. Okay, so that will be how you can count the number of positive values using Boolean aggregations. Okay, the logic is very similar. So if you want to see if there is any negative, so then you will do ARR less than 0, and then any. So basically that check if any of the values. So as long as it finds at least one false, oh no, excuse me, in this case, as long as it finds at least one true, because we're checking for negative, so it will return true if there is at least one negative value, and it will return false if all the values happen to be positive. And something similar here, if you want to see if any of the values is greater than 2, so then you will check if you want to see if all of the values are greater than 2, so then you will do ARR greater than 2 dot all. Okay, and that is going to return either true or false. True if all of the values happen to be greater than 2, false otherwise. Okay, here, why these methods matter in data analysis, again, is because here are 4 different reasons why they matter, or why you need to keep them in mind when you are analyzing your data and your data happens to be stored as a NumPy array. So number 1 is fast descriptive statistics on large data sets, meaning that these methods have been optimized in the sense that it will run fast. Okay, so in fact it will run faster if you decide to do a for loop to perform some sort of like a descriptive analysis aggregation. If you decide to do that type of calculation using a for loop, which you could do it, so if you decide to take that route, it's going to be much slower than if you decide to use maybe some of the functions or some of the NumPy methods that they already been built. Okay, so fast descriptive statistics, especially when the arrays are large. Okay. Second, efficient computation without explicit loops. Okay, so if you can avoid loops, take that route. Okay, loops in general, they tend to be slow in Python. Okay. Three, it has good integration with pandas and machine learning workflows, especially with scikit-learn, uh, with pandas, with TensorFlow, with PyTorch, and others. Number four, foundation for exploratory data analysis. So then again, the moment that you start computing averages, computing standard deviation, computing maximums, minimums, so you're exploring your data. So you're getting more familiar with your data. You are identifying potential trends. You're identifying potential common values in your data, which is going to give you a good foundation. So then you can start building models on top of that data. So it's the foundation for exploratory data analysis. And the last thing that I want to mention before we start with the exercises, a practical tip related to NumPy arrays for data analysis purposes is use NumPy vectorized aggregation whenever it's possible. Okay, so let me make this clear. So whenever you can use them, do it. Okay, they are much faster than Python for loops and escalate to millions of elements efficiently. So if you find yourself, again, doing a for loop, think about if you can avoid that for loop, especially if you want to do some sort of like, again, descriptive statistic aggregation. So there is a high chance that you can get away with that calculation without actually doing a for loop. And again, what I mean by descriptive statistics calculation, think about mean, median, standard deviation, maximum, minimum, all of those things. So don't perform those calculations with for loops because they will be slow. Okay, so using these methods or functions from NumPy, it will be much faster and it will be more efficient. Okay, so that is a practical tip. Again, if you have your data stored, not only if you have your data stored as a NumPy, but as I mentioned, right, so NumPy integrates really well with pandas and with other libraries, and you want to start exploring your data. So think about these methods, these functions that you may use to start analyzing your data. Okay. All right. So then now let's practice some of these techniques with 5 exercises. So let's get to that. All right. So here we have 5 exercises that will get us started with these methods in Python. Okay. So methods or functions that you may want to keep in mind if you want to start analyzing your data. So let's get to it. So exercise 1 says, given that we have a random array with 100 values in it, so count how many values are greater than 1.5 and set all the negative values to 0. So first, let's start by importing NumPy, or NumPy as NP. And we're going to set the seed. Okay, random seed. Let's use 42. And here we're going to say creating. Okay, with 100 values. So I'm going to say x equals to np random run n 100. So what are we doing up to this point is, first we're importing NumPy. Here we're setting the seed because we're gonna be creating values at random, and if we want to be able to reproduce the result, so it's highly recommended to set the seed. Okay, so and here we create the 100 values from a normal distribution with mean 0 and standard deviation equals to 1. Now what we need to do is how many values are greater than 1.5. So counting the values, so counting number of values greater than 1.5. Okay, so for that, it's just gonna be something like this, right? X greater than 1.5, that's gonna return true and falses. And then if I do just the sum of that, so it will count the number of truths, and that will represent how many values are greater than 1.5. Okay, and then the last part is set all the negative values to 0. Okay, we can print that, and then here we can say setting negative values to 0. So if I want to do that, so it's just first I need to identify the values that are less than 0, right? So again, so if I run this just for illustration purposes, so here x less than 0, so we see a bunch of true and falses. So then we need to count, or excuse me, we need to set those values equals to 0. Okay, so then this value or this index location needs to be set equals to 0. Okay, so for that we just do x apply to that and then equals to 0. Okay, so here let's print x, so we can see original array x and we can see the difference there, and then print the array after setting the values equals to 0. Okay, so we're ready to run this. So this is the original array with the random values from a normal distribution. From a normal distribution with mean 0, standard deviation equals to 1. So how many values are greater than 1.5? So it's 5. So let's see if we can identify those here. There is one here, another one here. That's 2. Let's see, where is the... Oh, there is another one here, 3. Let's see. 3, 4. I'm missing one. 4. Where is the other one? 1.5, 1.5, 1.5. I don't see the other one, but there are 5. Okay, so probably I just missed them somewhere. So this is the first one. There is 2. Okay, 2. So far is 2. 3. 3. Let's see. 4 and 5. So those are the 5 values. So then that's the reason why we see a 5 here. Now the last part is setting all the negative values to 0. So here this originally was negative 0.13, and then now is 0, is the second value. So all the negative values are set to 0, and this is how you can do that. Yep. All right, so let's go over exercise 2. It says create an array, a 6x3 array, so 6 rows, 3 columns of a standard normal values. Compute the column-wise mean, standard deviation, minimum, and the R max. Okay, so what we need to do here, so we don't need to import NumPy again. So let's creating a 2D array of 6,3. So let's call it X is np random run 6,3, and let's print. So this is the original 2D array, has 6 rows, 3 columns. Each of the values come from a normal distribution with mean 0 and standard deviation equals to 1. Now we're going to compute the mean column wise. So computing the mean of each column. So that will be x that mean axis equals to 0. Axis equal to 0 for column wise. So let's print that. So the mean of each of the columns is this one. So then if you take the average of this value, this, all the values on the first column is this number. Okay, same thing. This is represents the average of all the values in the second column. This represents the average of the values on the third column. Okay, what else do we need to do? Standard deviation. So computing the standard deviation of each row. Deviation of each row. That's it. Of each, no, excuse me, each column, not row, column. So axis 0. Okay, all right, so yeah, so then this represents the standard deviation of the values stored on the first column, the values stored on the second column, and so notice that this is changing anytime that I run this. It's changing a little bit because I haven't set the seed. So let's set the seed. np random seed. Yeah. Okay, now if I run it multiple times, I get the exact same value. So the same values. All right, the next part is the minimum and the argmax. Okay, so computing the minimum values of each column, that will be it. So that's just the min command. Yeah, so then here are the minimum values of each of the columns, and the last thing is the computing or extracting the argmax of each column. Okay, so then this is the index associated to the maximum value. So on the first column, the maximum value is this 1.57, and the index or the row number associated to that is 2. That is the reason why you see 2 here. Same thing happens here. The maximum value on the second column is 0.76, and the index associated to that is 2. The maximum value on the third column is this number right here, and the index associated to that value is 0. That's the reason why you see 2, 0, 0. Yep. All right, so let's go over exercise 3. So it says, given an array, replace the values greater than the mean with 1 and less than the mean with -1 and equal to the mean to 0. So let's start with this. So let's set the seed again, creating a 1D array. The array. Are we going to? No, I don't think I need to. Let's see. Yeah, let's create it at random. Okay. So creating 1D array. So x equals to np random rand. So let's create 20 of those. So that's the original array. So what we're going to do is, first we're going to compute the average of those 20 values. So computing mean. So the mean of the array is this number. So what we're going to do is all the values that happens to be greater than the mean. So for example, this one, they will be replaced by 1. And all the values less than the mean. So for example, this one right here, they will be replaced by -1. Okay, so for that, what we can do is we can use a function called where, which is part of NumPy, np where. Okay, so replacing. Okay, so what we can do is the following. So x, we can say x is equal np where. If the value is greater than the mean of x, then replace that with 1, comma. Okay, so that's the first thing that we need to do. And if it's less than a mean, -1, and equal to the mean, 0. So now here we can do nested. So if it's greater than the mean, we assign the value of 1, and then here we can do np where again. And then if x is less than the mean, then we assign the value of -1, else 0. And that will do it. Okay, so let's run this. All right, so this is the original array. This is the average. So then, as you can see, if none of the values happens to be exactly equal to the mean, so that's why we don't see any zeros. But then here we see a 1 because this happens to be greater than this. Same thing here. This happens to be greater than this. That's why we see a 1. And then here in this case, this value, the last value of the array, is less than the average, and that's why we see -1. So again, the purpose of this exercise is just to highlight how you can use the where command from NumPy. Okay, so then where it just works as if and else statement together. Okay, that's basically it. So first you need to enter what is that condition to be checked. The second argument is what do you want to assign if that condition is true. And the last argument is what do you want to assign if that condition is false. But then in this case, we are nesting np where, and that's fine. Okay. All right. So now let's go to exercise 4. So exercise 4 says for a daily returns array, compute cumulative returns. So that's just the product of the 1 plus the return and the rolling cumulative sum. Okay, so then this just will highlight how we can use cum prod and cum sum. Okay, so let's just start with setting the seed. I'm gonna use something else. It doesn't have to be 42 all the time. Let's use 1. Okay, creating a 1D array. So now I'm going to use np random and then run, just run. So run basically, or instead of run, we can also use uniform. Let's use uniform better. Okay, so and then let's create 20 of those. Let's say the returns, we can specify the limits, right? The minimum and the max from -0.2 or -0.02 to, let's say, 0.03. So those are the returns. So let's print those values. All right, so we have those 20 values that comes from a uniform distribution. The minimum value is -0.02, the maximum value is 0.03. Okay, very standard stuff. Now what we need to do is we need to compute the cumulative returns. So computing the cumulative return. So cumulative return is just going to be 1 plus the return, the cumulative product, and then we need to subtract 1. That's the formula. Okay. So and here we're just printing. This is just a finance formula. Okay. Let's print that. Okay. So these are the cumulative returns. Okay. So it's here you see the exact same value because you have only one value. Okay. Okay, and then let's also the cumulative sum. Okay, computing the cumulative sum. Cumulative sum. Let me see. Hold on, let me check this formula. Cumulative returns. I think I have the incorrect formula. So here it should be NP. The product, if I remember correctly, is the product of 1 plus the returns minus 1. Okay, so oops, is the product, and then so then cumulative returns is NP prod prod of the cumulative of 1 plus the returns, 1 plus cumulative returns. No, I think this is correct. Yes, yeah, and the come sum, yeah, that's it. Okay. All right, so then this is just illustrate how you can use prod and the cum sum. Okay. Now in the next part, exercise 5. So it says generate 1,000 sample, find the 50, and the 95 percentile. So okay, so let's create a set first. Let's use for now. Creating a 1D array. So we're going to generate 1,000 samples. Well, I don't need to print this because that will be too much data. And then computing the 5th percentile. So for that, we can use that percentile command from NumPy. And then we need to pass an array, and then we need to pass what is the percentile that we're interested in. In this case, we're interested in the 5th percentile. That's what we see. Well, that's why we enter 5. So the 5th percentile is negative 1.44. Basically, the 5th percentile represents the value so that 5% of the data is less than that value. That's basically the definition of the percentile. So then the 50 percentile is just the median. Okay. And in this case, the median is 0.05. Okay. 50 percentile, again, in plain English, is the value, the value in the data so that 50% of the data is less than that value. So then it's just technically the definition of the median because it split the data into 2 equal size buckets. Okay. Now computing the, what was the last one, the 95 percentile. And that's it. That's the 95 percentile. So 1.63. Okay, and again, the 95 percentile represents the value so that 95% of the data is less than that value, less than or equal to that value. Okay. All right, so then these exercises just highlights how you can, rely on these methods or functions from NumPy, so then you can start exploring your data. So again, anytime that you can use one of these methods, go ahead and do it and avoid using for loops. And I do understand that there may be some scenarios in which you need to use a for loop, and that is fine. But if you can avoid using a for loop, do it because it will speed up your program. Okay. All right, so that's all I have for this tutorial. See you on the next one.